Okay, so I know that the title of this section is adding, subtracting, and graphing polynomials, but we're going to save the graphing part for college algebra, so we're just going to do the adding and subtracting polynomials. But first we need a little bit of terminology. Okay, so what it means to be a term are terms are separated completely by plus and minus signs. So each one of these are terms of this polynomial, right? Terms. And it didn't matter if there were minus signs in between there. What's tricky is, think about this. That's one term. Because they're not separated completely by plus and minus signs, that's one term. However, if I distributed it and wrote it like this, now it's two terms. Terms are separated completely by plus and minus signs. Okay, so the first one is called the leading term, right? And the coefficients of the terms are just the numerical parts. So the coefficient of this term is 4, of this one 6, of this one 5. And this term here that doesn't have a variable, it can either be called a constant term or it can be thought of with the variable. Remember from the last section we said anything to the 0 power is 1. So really it could be thought of as there's an x to the 0 as its variable part. Okay, so then it could also be considered the coefficient of that term, but a lot of times we'll just call that the constant term. Okay, now none of these had negatives, but if we would have had a negative 5x right here, the coefficient of this would be negative 5. Remember, the sign in front of the number is part of that number. So terms, coefficients, and the constant term. All right, so name the coefficient of each term in the expression and give the number of terms. Okay, well, there's two terms separated completely by plus and minus signs. We'll see that there's two terms. Okay, the coefficient of this term is a 2. And what do you think the coefficient of this term is? I hope you said if there's not a number written, it's understood to be a 1. And so the coefficient of that term is negative 1. So here's your coefficients, and it's two terms. All right, a little more terminology, vocabulary. Okay, like terms, or terms that are alike. We've already been using that terminology actually. So that means they have to have the exact variables and exact exponents on each variable. The only thing that can differ is the numeral part, the coefficient. So 19m to the 5th and 14m to the 5th, those are like terms. 6y to the 9th, negative 37y to the 9th, and y to like terms. These are not like terms. 7x, 7y, variables are different. Not like terms. Z to the 4th, z, exponents are different. Not like terms. 2pq and 2p don't have the same variables. Okay, to add and subtract these polynomials, all I got to do is combine the like terms. The only thing we can do is combine terms that are alike, right? Think about this. If you're going to add a pencil and an eraser, you can't combine them and say you have two erasers. No, it doesn't make sense. If I had a pencil and another pencil, I could say I have two pencils, right? So we can only combine the things that are alike. Okay, so it says combine like terms. So the only thing I could add to that, and by the way, I suggest you also find some way of marking your terms to make sure you've dealt with them. A lot of people mark them out after they combine them. I like to leave that for ones that add to be 0, but it's whatever your preference is. You'll see in a minute when they're really long, it's really important. So I'm looking across here. The only thing I can add to this is another r squared. Oh, I have one. So then, if I have one r squared thingy, whatever that is, and I've got 5 more of the same r squareds, then altogether I would have 6 of those r squared things, whatever that is. And then I can see, well, the only thing that I have left is a 3r. Okay, so down here, the only thing I can add to this is if I have another x squared. Since I don't have another x squared, and there's nothing alike, that's it. Okay, more vocabulary. Degree of a term is the sum of its exponents. So if this is our term, the degree of this term is a 4. The degree of this term, you can think of it as having an exponent of 1, so it's a first degree. The degree of this term, remember, if I have a constant, I can imagine that it's because it's times 1 written as x to the 0, so it's a 0 degree term. And the degree of this one, you add the exponents, so 2 plus 1 is 3. So if we had 2x to the 5th, y to the 7th, z squared, the degree is 5 plus 7 is 12 plus 2, it's 14th degree. Okay, so that's how to find the degree of a term. If you want to know the degree of the polynomial, and that's what you're going to be asked mostly, what's the degree of the polynomial, the entire thing, it's whatever the degree of the largest term is. So these degrees are 4, 2, 0. So you choose don't add them together, not for a polynomial. You just choose the largest degree. This degree is 1, 0, so it's a first degree. These have degrees of 3, 2, and 2, so it's a third degree. So this has a degree of 5 and a degree of 6, so the polynomial is a degree of 6. So for polynomials, you just choose the term with the largest degree. Now, we also have particular terms for some polynomials. If it has one term, as in these, then it's called a monomial. That prefix mono means 1. If your polynomial has 2 terms, then it's called a binomial, because that prefix bi means 2. If it has 3 terms, it's called a trinomial, because that prefix tri means 3. For polynomials with 4 or more terms, we just call them polynomials, because that prefix poly means many. Okay, so I need to know monomial, binomial, trinomial. They're all polynomials, but these have more specific names also. Okay. Simplify. Give the degree and tell whether the simplified polynomial is a monomial, a binomial, a trinomial, or none of these. These do not have like terms. It is as simplified as it can get. Since it has 2 terms, it's a binomial. Okay, this is an x, this is an x, and that's an x. Hey, I can combine all of those terms all together. So 12x's minus 14x's. 12 minus 14 is negative 2. Negative 2 plus 3 is negative 1. So there it is, and that gave me a monomial. And finally, see, this is xy, that's an xy, that's an xy. Hey, I can combine them all again. 6 of these xy things, if you take away 7 of the same xy things, you'd have negative 1. And then if you add 3 more, you'd have 2 of those xy things. And it's a monomial because it just has one term. Okay, so one thing we can do with polynomials is we can evaluate them. So if you're told the value of the variables that's in the polynomial, you can just plug in. If y is -1, then I'm just going to plug a -1 in everywhere there's a y. Everything else will stay exactly the same, except I replace the y's with -1. Now, I got to take care of these exponents. -1 cubed, 3 negatives is a negative, so this is the same thing as just 2 times -1. Then I'm going to do my multiplication. 2 times -1 is -2. 8 times -1 is -8, and -6. So -2 minus 8 is -10, minus 6, -16, if y is -1. Okay, find each sum. We got a couple of choices for that. I can write it like this: 4x cubed minus 3x squared plus 2x. And because it's a sum, I'm just going to add 6x cubed plus 2x squared minus 3x. And then it doesn't matter how many terms we have. It's the same process as I was doing when we just had, 2 or 3 terms to combine. The only thing I can add to this is if there's another x cubed. So there we are. 4 x cubed things plus 6 more. I have 10 x cubes. There's an x squared, and there's an x squared. So minus 3x squared plus 2x squared, that's minus x squared. Now I'm looking to see if there's any more x's, and there are. 2x minus 3x, that's minus x. And because I kept up with what I was doing along the way, I can tell at a glance that I've accounted for every single term. Now another option we have that I'm just going to talk about once, if you prefer it, you can add them vertically. So you can write the first one the same. And then you line this up under the like parts. So it kind of helps you see which ones you can add together. I really don't like this way. If you do, that's fine. But it really gets people in trouble when we're subtracting polynomials. But right here, I'm just going to combine the ones that's the same, and lining them up vertically might help us see, what's the same. So that's an option, and you've got a couple of homeworks that's going to ask you to do it that way, but this is by far preferred, and you'll see why as the problems get a little bit more complicated. Okay, so once again we're going to add these, so it just means, I've got x squared minus 2x plus 5, and I'm going to add 4x squared minus 2 to it. Okay, so I'm looking for an x squared all the way across. There's one. So altogether that's 5x squared, 1 plus 4. And now I'm looking for just x's. Oh, there's no more. So nothing will combine with that. It's just going to stay minus 2x. Now I'm looking for constants. 5 minus 2 is a positive 3. Okay, now this one's already got it written for us with the plus in between there. But notice here's a trinomial. We're adding another trinomial too. Since there's pluses outside the parentheses, I can just drop those parentheses. They're not needed for anything if there's just a positive 1 in front. Okay, looking for anything that's next to the fourth. 2 minus 3 will give me negative 1x to the fourth. Anything that's an x squared. 5x squared minus 6x squared. Anything that's just a constant. 7 plus 2, and I can tell from a glance that I've accounted for every term because I marked it. Okay, now on subtraction, we got to be really, really careful because this is a 1 times everything. It doesn't change. But this is a -1. So I've got to distribute that -1 to each term. Be careful about that. Negative, negative is a positive. Negative times a positive is minus, and same thing again, -6. Now, looking for anything that's a y squared. 7 of them and 3 of them, 10 of them. Looking for anything that's just a y. -11 minus 4, -15 of them. Looking for anything that's just a constant. 8 minus 6, 2. Right? And again, from a glance, because we marked it somehow, I can tell I've accounted for every term. Okay, subtraction, everything about subtraction we got to be really careful about. Read this. It says, take this from this. I can't just put a minus in here. It says this from this. I'm starting with this one. So it's 14y cubed minus 6y squared plus 2y minus 5. And then I'm going to take this. Now, I've got to be careful again because I'm going to take that whole thing. So that means that negative has to be distributed in there. So really, my problem before I can combine is 14y cubed minus 6y squared plus 2y minus 5 minus 2y cubed plus 7y squared plus 4y minus 6. Had to distribute that negative. Now, anything that's a y cubed, all the way across. 14 minus 2, 12y cubed. Anything that's a y squared, all the way across. 7 minus 6, 1y squared. Anything that's just a y. 2 plus 4. Anything that's just a constant. Typically, I don't know why I did 4 there. Usually once I do 3, then I change to zigzags. Because at some point, extra lines is just too confusing. Okay, -5 minus 6. -11. And voila. But be careful on all the subtraction ones. Do a double take on every one. Here's another one. They've got it lined up for you. They want you to do it vertically. I suggest never doing them vertically, but whatever. Some people like that, so you can. But because it's a subtraction, it means I got to subtract that, and I'm subtracting this. So really, that's a minus minus, and then that's a minus. We don't have to worry about that when we're adding, right? We're just combining them signs as they are. But when I'm subtracting, I got to first figure out my signs. And then I got 14y cubed minus 2y cubed. -6y squared plus 7y squared. Look, I don't have another y to add to that. And I don't have another constant. So there's an example of a vertical if you so choose. You can do it that way. But then look at ones like this. Right? I'm adding and subtracting this polynomial, this trinomial, and this trinomial. So I'm just going to distribute that negative. So my first step, this is just a 1. So having a 1 doesn't change anything in this polynomial. But having a -1, I have to change the signs of everything in here. That's what distributing a negative will do, right? And then I'm back to just multiplying by 1, and multiplying by a +1 doesn't change anything. All right, the only thing I can combine to this is if there's another one that's a t to the 4th, and we actually had 3 of them this time. 3 of them plus 2 of them, now I've got 5. I'm going to add one more, 6 t to the 4th. Okay, anything that's a t cubed. Nope, no other t cubes. Okay, anything that's just a t. Yeah, just a t. Okay, minus 8t, minus 6t, so minus 14t. Okay, anything that's just a constant. All right, so 3 plus 6 is 9, plus 6 is 15. And I can tell at a glance that, look, I've missed this term. Right, now there's not another t squared. I don't mean I missed it in my adding. I just mean I want to make sure that I include that in my answer. Right? It's real easy to go down here and think, oh, I'm at the constant, so I'm done. But if you haven't marked them so that I can see that I haven't taken care of one of the terms, I might miss it. All right, let's do it one more time. It's a subtraction. So I've got to distribute that negative, which is going to change my signs of everything in that next trinomial. So it'll be minus 7m cubed n plus m squared n squared minus 6mn. Now remember, all variables and all exponents have to be the same. So I'm looking for an m cubed n. Oh, here's one. Okay, 5 minus 7 minus 2 m cubed n. Okay, now it's got to be m squared n squared. Oh, here's one. 3 plus 1 is 4. Okay, now just plain mn. Minus 4, minus 6, so minus 10 of those mn things. Perfect. Adding and subtracting polynomials. Okay, let me know.